Hello and welcome. Thank you for joining this session, Getting to Yes, Minimum Viable Cloud with Maximum Security. My name is Ilya Epstein. I'm a solutions architect with AWS. I've been with AWS for 2.5 years, working primarily with financial services organizations. I'm joined here by Mayank Jain from Vanguard Security Organization. I had the privilege of working with the Vanguard team and Mayank for the last 2 years on their journey to yes. So we're going to start with some of the common challenges to getting to yes. Now, what we mean by getting to yes is, how does an organization get comfortable with running mission-critical workloads in the cloud without compromising on security or compliance? Mayank is going to do a deeper dive into Vanguard's journey and how they addressed these challenges and some of the best practices and lessons learned that you could actually take back to your organizations. I'm then going to do a deeper dive into the AWS Cloud Adoption Framework, specifically the security perspective, and show you how that could be used as a tool to develop your security controls for the cloud. And then we're going to finish off talking about DefSec Ops and how those principles could be used to evolve your controls over time. So over the last several years, we've seen a major shift within the financial services industry in terms of public cloud adoption. For most organizations, it's no longer a question of if, it's a question of when and how fast can we get there. But the journey to running critical workloads in the cloud still varies by customer, and there are some critical challenges. One of the challenges we see in the area of security compliance is often around the actual security controls. For example, what security frameworks do we use? We have CIS, we have CSA, FedRAMP, NIST. Which one is right for our organization? How do we make that choice? A lot of organizations have existing security controls in the cloud. Do those security controls easily transfer into the cloud? Could we simply use those? We have different workloads, different data types. Could we simply apply those controls uniformly across all these different environments? We also often see a challenge in terms of the knowledge within the cloud. Very often, it's very hard to have a discussion around security controls if everyone on the team is not speaking the same language. So it's not just important your engineers and developers are familiar with the cloud, the security and compliance teams really need to be familiar as well. So how do you bridge that gap? I also often see a lot of time spent on tools-focused discussions instead of focusing on the actual control objectives. Customers a lot of times spend time figuring out if the existing tooling will work in the cloud. So how do you reverse that conversation and focus on the control objectives? So in short, where do we begin? Now, before showing you how the cloud adoption framework could be used to help you develop these controls and some of the patterns for success, I'm going to hand it over to Mayank, who's going to show you how Vanguard approached this and their journey to yes.
Great. All right, thank you, Ilya. So as Ilya said, my name is Mayank Jain. I'm an architect manager at Vanguard, and I belong to the enterprise security organization. I manage a team of application security architects and a small team doing innovation and research related to security projects. So I was fortunate enough to be part of the cloud journey from the very beginning, and also partnering with Ilya and the AWS team in order to move us to AWS. So getting to yes, so sounds like getting into a marriage, right? But hopefully I can tell you a few things that we learned and the critical role of controls that got us to yes. So before we start, a little bit about Vanguard. As you may know, we are one of the world's largest investment companies. We provide low-cost mutual funds and ETFs to our shareholders. And one of the reasons for the low cost is our unique structure, where there's very little to no overhead, and we charge a very small expense fee for our funds. So this should sound familiar to you, right? Like AWS, very little overhead. You pay for what you use. So the cost structures are very well aligned between our companies, and there's definitely a cost play in order for Vanguard to use AWS in order to further reduce our expense ratios and provide more returns back to our investors. So we started this journey, and as you can see, one of our oldest fund is the Wellington Fund, which still exists. And it was due to some of our senior leaders going to Wellington and pivoting our journey from a hybrid cloud to a public cloud approach. So Wellington is what kind of got us to the cloud, or actually they kind of started us on the cloud. So we got the initial yes of going to the cloud. So that was kind of in our marriage analogy, like the engagement kind of happened. So how do we move forward in terms of making sure that we could get critical workloads to the cloud? So once the initial OK was given, we created a team of engineers from different areas of Vanguard, security being one of them. And we got engineers from infrastructure, from our chief technology office, and others to kind of assemble together and then start our journey. One key thing over here was we took an MVC approach, where MVC stands for Minimum Viable Cloud, where small but meaningful workloads are put all the way from development to production. So we had to have this team wrap their heads around what MVC meant. And then once they bought into that idea, we kind of evangelized that to other teams within Vanguard. But that was critical for us in order for us to kind of start this journey and make sure that we started on a small footing, but were able to move to production in a quicker manner. So we kind of got this team together. Education was key, like as Elias stated. We provided a lot of training, both in terms of formal and informal training, and AWS provided us with some targeted learning as well to kind of focus the team and make sure that everybody was on the same page. This training was not just for the technical teams. Folks on legal compliance and other areas were also vital in order for them to understand what the cloud was. So we got just-in-time training. We had our first pilot so as to say into production in early 2016. And that really laid the foundation for us to put our first 2 MVCs in production in 2016. And we followed the same MVC concept this year as well. So a little bit about the team. And this was critical. We kind of had the steering committee at the highest level, and they provided their backing to us. And below them were 2 areas which I can call functional and non-functional, which is the IT and security team, or the technicians, and the security legal team on the other side that were really going to give us that yes in order to move forward. And underneath those teams were the actual teams doing the work, which is the cloud construction team, the infrastructure team, and then the application workloads who had to do the actual implementation. So one big thing about this team structure was we were co-located. So we were all together in one area, and that literally broke barriers for us in order for us to move at the pace and move to production. So how did we define these controls? So some of the ones that you see up there, as we are regulated, we adhere to them. We pay very close attention to SOC 1 and SOC 2 controls, and we make sure that the services, AWS services that we use are compliant, so they do their attestation, and then in a shared responsibility model, we do our attestation as well, and then build upon it. So how do these controls really form? So we were fortunate enough to work with our enterprise risk team, whose job it is to create these controls and define for a project like ours to move forward with. So they kind of work with us, define the controls, and then validated those controls as well as we were developing in order to give assurance to our steering committee in order for us to move forward. But these controls were on-premise controls, so they didn't really make up the entire set of controls that we had to implement. So we took input from other areas. There were 3 main areas. So one were the existing controls that we talked about, and the second set were the AWS controls that they already attested to. And the third set of controls were what we call it the CCRA, or our Cloud Cybersecurity Reference Architecture, which defined cloud-specific controls that needed to be implemented. So these 3 kind of came together and created a gold copy for us so that the MVC 1 and 2 workloads were able to implement. A little bit about the CCRA. So CCRA was formed based on our existing standards and best practices that we had both on the application and infrastructure side. And we looked at the authoritative sources like NIST and CSA and created 3 volumes of the CCRA, going from volume 1, from conceptual all the way down to design control. So this created a framework for us to talk between the different teams, both on the technical and non-technical side, so that we understand each other. And security played a key role over here in terms of translating some of these controls over from legal compliance to the people doing cloud construction and vice versa as well. We aligned ourselves closely to the NIST, as some of our existing standards are already based off of that. So let's dig a little bit deeper in terms of what these cloud controls, how are they implemented? So like I said before, there were different teams that were created in this MVC framework. And once we had this gold copy of controls defined, we divvied it up to different teams. So there was clear ownership in terms of which teams needed to implement what controls. And the way the controls were implemented, we defined something called a control procedure, where the teams defined in simple English terms what these controls meant, so that the enterprise risk team could validate those controls and make sure that we have evidence of these controls going forward. So these control stories were created by these teams in terms of having them included in their JIRA boards. In addition to their functional stories, we made sure that these control stories were also created and implemented over time. And as they were implemented, the steering committee got a clear view in terms of what controls were implemented to see progress and make sure that we got to yes. So some of these control procedures were obviously different because the cloud brings different concepts to the table. We didn't have any physical firewalls in place. We have stuff like security groups and NACLs. So our control procedures had to reflect that. Same with leveraging AWS native services like IAM and KMS. We made sure that the control procedures clearly defined, what these controls, how were they implemented. So when they were evidenced, they were very clear from what we had done. So this is what kind of got us to yes in terms of making sure that these controls were implemented in a progressive manner. So now that we have the framework for MVC1 and MVC2, we've kind of formalized the process. So as different workloads are being moved to Amazon, we have the same controls framework that are applied, and we have different gates in place today to make sure that these controls are baselined upon the work that was done in MVC1 and MVC2, and make sure that they're enhanced for specific requirements that new workloads bring to the table. So what you've heard so far are controls that are more directive, they're more detective in nature, and we validated that by the help of AWS professional services. But we want to mature our controls even more. So we kind of pivoted towards preventative controls, which are kind of a natural fit in terms of the DevOps pipeline. Infusing security into these build pipelines is relatively easy, and scanning of both the application and infrastructure as code to make sure that they follow security rules is very straightforward. So we've done that. By no means we are mature over here, but we are kind of starting that journey where we can break the build or tear down the stack if need be. A few lessons learned over here in terms of getting to that stage. Obviously start slow. Make sure that your workloads that have these security rules enabled for doing security scans, that they're in observe mode for a while, that you can weed out the false positives, and then when you're very sure, make sure that when the stacks are broken or the build is broken, that you know exactly what's going on. Another thing over here is make sure that you work with all the stakeholders and clearly define what these rules are that will break the build, so there is common understanding and everybody knows the exact reason, why the build was broken. So brings me to my final slide over here in terms of lessons learned. So skill set is a big one in terms of not just the technical team, but the legal compliance teams also understanding, what the cloud is all about. So invest in training, invest making sure that all of the parties know what the cloud is all about, and have the expertise at different levels. The controls that I talked about, the design of the controls was done in an iterative manner. And the implementation and the evidencing was also done in an iterative manner. So make sure that the team is co-located and they're in the same place. So the speed to delivery is much faster over there, and everybody understands each other too. Ongoing compliance, so as I mentioned, SOC 1, SOC 2 are key areas that we look at in terms of AWS services being compliant. But if they're not, work with your AWS team, make sure that they have a roadmap for the services that you're interested in making sure that they get compliant in the time frame that you require. And lastly, just uncertainty of new regulations. So GDPR is in forefront in terms of what's coming in 2018 for us. So make sure that the controls that you already have created are baseline and then they're actively managed. And if there's new capabilities that come to the table, that these controls are refreshed and kept up to date. So new regulations like GDPR, you can kind of adjust the incremental controls over there. So with that, I'll hand it over to Ilya, who's going to talk about AWS specific controls.
Thank you, Mayank. I think really impressive in terms of the journey in such a short time frame and for an organization of this size. So in the last couple of years, I've seen some real patterns for success in terms of cloud journeys and how do you get to yes. So I want to cover some of those and then really go deeper into the cloud adoption framework and show you some examples of actually implementing end-to-end controls. So in terms of some of the patterns for success, which I think the Vanguard team really leveraged very well, educate and experiment is really important. And a lot of customers, kind of start thinking about sandbox and having, environments where their engineering and development teams could test different services. That's definitely important, but it's even more important for your security and compliance teams, right? They really, in order to have a discussion around controls and controls objectives, it's very hard to have that discussion if the security and compliance teams are not hands-on with AWS services. So definitely encourage you to have environments where the security teams and the compliance teams, and in some cases even the risk teams, could actually be training and have some hands-on exposure with AWS services. Establishing the cloud team is really important. This co-location that Mayank talked about, it's really something really significant, right? I've been spending 2 years at the Vanguard team once a week, and seeing the energy where you have all the different teams that have never really worked together be in one place is really, really important. Most successful cloud journeys will also have a partner. That's typically what we see. And we have great partners both in terms of financial services as well as security competency. This concept of minimum viable cloud, we're going to dig deeper over the next couple of slides, is really important as well, right? For most companies, it's very hard to start deploying all of the production applications at once. You need to take this iterative approach where you are deploying some meaningful workloads, and that becomes your test bed for iterating the controls over time. And once you do this a few times, that will get you ready for the actual critical workloads in the cloud. So let's talk a little bit about the MVC. What are the key ingredients to an MVC? I do want to give a credit to some of our partners in this space. One partner specifically, the cloud technology partners, I'll call them out, CTP, they really perfected this model. I worked on several projects with them that were very successful. And what are some of these key ingredients? The first one is establishing the landing zone. This landing zone has to be a CISO-approved landing zone, right? This is not some type of a side project. This is a landing zone which has your account structure, your VPC structure, identity and access management, logging and monitoring, key foundational security controls, where the CISO team could sign off and allow you to deploy a couple of meaningful workloads to the cloud. Again, this cannot be a science experiment. This has to be something that's meaningful, because the whole idea is you're trying to test out a whole set of controls. So this has to be something that people have the skin in the game, and something that will actually be able to test dozens or hundreds of different controls. Do not fear backlog, right? It's okay to have backlogs. You will always have backlogs. Just like in product development, it's good to have backlog. In security, it's the same thing. It's a healthy thing to have that backlog that you could continuously iterate through. And I'm going to talk more about it as we go through DefSec Ops. And of course, you want to establish baseline security. You want to have that fundamental security that will take care of maybe 75% of your controls for the initial workloads, and then you could iterate with additional workloads as they get onboarded. What you're trying to do is you're trying to test out, really, if you think about it, the 6 capabilities of the cloud adoption framework as part of this MVC. So from a business perspective, you want to start developing a framework for building a business case that justifies moving a workload to the cloud. From a people perspective, you're trying to build a cross-functional team that will allow you to educate the rest of your organization on the cloud. From a governance perspective, you're going to start implementing some guardrails. These guardrails could be both in terms of compliance, but it could also be cost guardrails. Now, you're not going to be able to develop all the guardrails at once. You really need the experience of deployment to even understand what type of guardrails you're going to need. From a platform perspective, this is where you're going to make a selection of which AWS services you're going to use. Are we going to use a managed database? Are we going to use a database on EC2? Are we going to use SOC 2 services? And then you're also developing your CICD pipeline, as well as all the tooling that goes with that CICD pipeline. From an operations perspective, what we typically see successful is customers forming a small tiger team, whether it's DevOps or Ops, that is going to take care of those initial MVC workloads, and that tiger team eventually will become the kind of the nucleus that will retransform the rest of your operations organization. Sometimes it's hard to kind of train your entire operations team at once. It's usually easier to have a small team that could actually be an enabler for the rest of the organization. And then from a security perspective, we're going to dive deeper. This is where you're establishing the key security foundations and the baselines for your deployments. So let's go deeper into the cloud adoption framework security perspective, because this is really where customers in financial services spend most of their time. If you look at the cloud adoption framework security perspective, what it does is it breaks out all the controls into 10 epics. There are 5 core epics and 5 augmented epics. The core epics are things that you would expect, right? Identity and access management, logging and monitoring, incident response, maybe data protection. And then the augmented ones will be around more specific to the different types of workloads that you're running. Maybe it's around big data analytics. Maybe it's around your CICD pipeline security. But what the cloud adoption framework also does is it breaks out all of the controls into 4 components. And those are directive components, preventive, detective, and responsive. And classifying these controls into these 4 buckets really helps you develop these controls. And I'm going to show you by example how you do that. So let's start with the first one, the directive component. The directive component is the guidance to the people that are actually implementing your cloud, and it's the guidance for the people that are operating in your cloud securely. So this is going to include all of your policies and procedures. In the case of Vanguard, it's the CCRA. And that includes account governance, account ownership, data locality requirements, least privilege access, all of the things you would expect from a policy and procedure perspective. So how do you start there, right? That's usually a challenge. So what we recommend is to leverage an agile process. Just like your developers are developing in an agile phase, apply the same concept to security. Treat security as a piece of code. So create user stories. If they're large user stories, create epics, group these epics into themes, create a backlog, have sprints, and then continuously iterate through that process using the same, even tooling in many cases, as your development organization is doing. Now, I'm not going to be able to go through all the user stories in the 10 epics of the cloud adoption framework, but I'm going to zoom in on a few of them and walk you them end to end. And here I picked EC2 instance security, specifically around patch management. So as an example, right, I'm a product owner, and I would like to apply patches as early as possible to reduce the risk of an opportunity for an attack. So that user story could be based on an existing control you have. You make it more AWS specific by talking about your specific resources in AWS. So maybe, I would like to apply patches to my staging account or a VPC. I want to test it, I want to rescan it, and then automatically deploy it and push it to production. And then you define an acceptance criteria. So in this case, the acceptance criteria could be an AMI bakery process, which automatically creates the latest AMIs. Another example, I would like to enforce the users to only use approved AMIs, only use approved Amazon machine images. From an AWS perspective, I only want to allow deployment of AMIs that are golden AMIs, and those golden AMIs were created by my AMI bakery process. So how do I implement that control? What's my success criteria? One of the approaches could be, for example, is leveraging IAM policies to restrict which AMIs the users could use. I'm not going to read through the rest of these, but I'm going to cover them over the next few slides. So we have our directives, and then the next step is to actually implement these controls. And the first approach is to leverage preventive controls. The preventive controls are the actual implementations of identity and access management, infrastructure protection, and data protection that you have specified in your directives. The key idea of these preventive controls is to actually mitigate threat and vulnerabilities from ever happening in your environment. So going back to our example, right, if I have a requirement that says my users could only launch an EC2 instance using an approved AMI, one of the ways I could do that potentially is through identity and access management and create an IAM policy. It could be a resource-based policy, or it could be a tag-based policy, iterating the specific AMI IDs, or based on a tag, if I have AMIs that have a golden tag, those are the only ones that the users are allowed to create. Now, this, of course, assumes other controls in place, because, for example, if you're using a tag-based approach, this assumes that that golden AMI tag could only be set by the IAM role of the AMI bakery process, right? And no other user or no other role could actually go ahead and modify that tag. So there's some assumptions being made that it's not just one control. You may actually have to have multiple controls to go ahead and achieve the success criteria. So this is one example. I'm going to show you later on. There's another way to achieve a preventive control that, from a control objective, does the same thing, but perhaps is a little bit more optimal. So we have our directives, we have our preventive control. The next step is you want to have detective controls. And this is a layered security model, because just because you're preventing something, you can't always prevent everything. What you really need to be able to do also is detect and have full transparency into your AWS resources. So the detective component is all about logging and monitoring, security testing, asset inventory, change detection. It's the full transparency into your environment. So from a user story perspective, what I wanted to do is I want to make sure that when I spin up an EC2 instance, I want to verify that it was using the approved AMI. So how am I going to do that? And also one other thing I want to mention, it's really important when we talk about detective controls, it's not just about some best practices about log aggregation and turning on CloudTrail. It's actually applying some intelligence and maybe even machine learning to those logs and actually do something about them, right? Take action. And in an ideal phase, you want to actually have a automated remediation that will actually act upon those logs. So this is an example of how you could achieve this. We're going to use here a service called CloudWatch Events. CloudWatch Events is a service, it's an event bus, where events could be put on that bus by different AWS services when a change of resources happen. So in this example, I'm going to have an EC2 instance. When that EC2 instance spins up, it generates an event change that the instance is now running. That event could then have a rule applied to it, which could then point to a target. Now, that target could be a Lambda function. It could also be other things like a Kinesis stream. It could be a run command from System Manager. In this case, I'm using a Lambda function. And this Lambda function is actually going to look at the event and is going to look at the AMI ID that that instance was launched from. And then it's going to do a lookup into a DynamoDB table. And the DynamoDB table is going to contain all of the approved AMIs. If that AMI ID matches, it's on the approved list, the instance could continue to run. But if it was not approved, the Lambda function will actually terminate that instance and perhaps notify the user. So this is an example of a detective control after the resource has already been launched. I want to show you another example, and that is to use something like EC2 System Manager, change state manager. And the idea here is not just to verify an AMI, but actually look for configuration drift. What if I want to go beyond just checking the AMI? What if I want to make sure that my key configuration files, like antivirus settings or IP tables, I want to detect when a configuration drift has occurred, and I want to take action and remediate it. So with System Manager, what you could do is you could create configuration policies, which includes not just OS, but also these additional configuration files. And you could create a schedule where that instance is automatically checked against that policy. And if there's a drift in the configuration, System Manager could actually go ahead and reapply the policy. So it's another example where you're not just using logging, but you're actually acting upon an event and then doing an immediate remediation. So we have our directives, we have our preventive controls, we have our detective controls. The next step is to have responsive controls. And responsive controls are important to deal with incident response, or to be able to do forensics, for example, if that EC2 instance is compromised. Now, one of the best practices in terms of forensics is to isolate the instance, or isolate, let's say, a server, and preserve the state to as much as possible to when that issue has occurred. So for that reason, one of the best practices that we recommend is to actually leverage a security group. It could be a special quarantine security group that the forensics team could apply either to an EC2 instance or to an entire application stack that was affected. Now, this, of course, assumes that the forensics team actually has an IAM role in the different accounts to be able to assume and apply that security group either on demand or they always have that privilege. The actual forensics could be done, let's say, from a forensics instance. That instance, again, could either be running in the forensics account or it could just be an AMI that could be spun up, and that has all the forensics tooling on it. And they could do things like a memory dump, they could take snapshots of the root and data volumes, and they could also back up all the artifacts, any log files, anything they need from that instance into an S3 bucket that the forensics team owns. Now, one of the things around the responsive controls, it's not just enough to have the run books, it's really important to exercise this. So we always recommend to have game days where you actually exercising and making sure that you have the capability to do forensics in the cloud when the issue occurs. So we talked about the 4 components of the cloud adoption framework. Now let's talk a little bit about maturing these controls through DefSec Ops. With DefSec Ops, what you're trying to accomplish is that these controls should not live externally to your CICD pipeline, but they should actually be integrated as part of that CICD pipeline. The security team should actually be producing code or developing or contributing to the overall CICD pipeline. And all the controls that we talked about could actually be built into that pipeline. Now, what this also allows you to do is it allows you to achieve the desired control objective at the most optimal phase of the deployment. So for example, when we talked about that first preventive control, instead of checking to see if the user has the permission to use a specific AMI and doing this from identity and access management perspective, I could do this much earlier. When the user commits the code, let's say it's CloudFormation or it's Terraform or whatever automation or orchestration tools you use, you could have static code analysis that will check that template and see what AMI IDs am I using. And if I'm not using the proper AMI ID, I could actually prevent it from ever going to the build phase. So this is actually potentially a better approach because you're not even making an API call to AWS, you're actually tearing down the build earlier on. The same thing with build, deploy, and production stages. So this is an example of how you could implement a CICD pipeline with those security controls. So let's assume we have users that are pushing code. And again, this code could be CloudFormation templates, it could be Terraform. And in this case, they're committing that code to AWS code commit, but it doesn't have to be code commit, it could be any repo. And then we're using code pipeline to deploy the code. So what we're doing here is we have Lambda functions that are, let's say the first Lambda function is actually doing a static code analysis on that commit phase and making sure, for example, that the AMI in the code is one that's allowed. And if not, it actually will prevent it from going to the build phase. Now, in the build phase, where you actually are deploying some resources, maybe not in production, but in lower environments, in that phase, potentially, you could start interrogating the actual resources that are being created. So, for example, you could actually see if the AMI of that instance is one that's approved. Or you could actually look dynamically the relationships between your tiers within an application stack and whether they have the appropriate security groups. So you could perform additional steps or checks once the build process has occurred. And then to go to the production or the final stage of your deployment, you have additional checks that you could implement. Now, it's okay to implement those checks even if they're not fully automated, even if they're manual. But what's nice about this approach is having it part of your deployment pipeline and not just an external process that kicks off. And then over time, you can actually measure and see how can I turn some of these manual processes or manual approvals into automated steps. So what are some of the benefits from a DefSec Ops perspective? It gives you confidence that the code is validated against security policies. You really have unified security configurations across all of the environments. It really helps you increase the agility of your team. Now, when we talk about increasing agility of the team, it should be something that you can measure, right? So, for example, some organizations measure it based on how much code the security team is actually contributing to the CI/CD pipeline. Or let's say in our example of the user stories, what's our mean time to patch? Or what's our mean time to perform a forensics in case an incident has occurred. These are all the types of KPIs that you should be measuring to actually see if moving to DefSec Ops, and as you iterate through DefSec Ops, what kind of benefits it's giving you to your security organization. And then ultimately, what it's really helping you do is helping with security at scale, right? Because if your development teams are going into the cloud and they're doing hundreds or thousands of deployments per year, as opposed to just a handful of deployments that you may be doing on-prem, the only way the security team could scale and not be a bottleneck is if they're actually participating and contributing to the same CI/CD pipeline. So in summary, I think we talked about some of the patterns for success in terms of experimentation, building a cloud team, iterating through the MVC process. We talked about how you develop an agile process for developing the controls for the cloud. I think the cloud adoption framework, I think it's a great asset, sometimes overlooked in terms of how it could actually be used as a blueprint to help you develop those controls. And then, of course, maturing the controls over time through DefSec Ops is definitely another thing that we're seeing customers do as they mature through the cloud. Thank you very much for attending the session. I think we're wrapping up a little bit early, but we'll be able to take some questions after the session. Mayank and myself are around. Please complete your evaluations, and thank you very much.